Good morning or afternoon, everyone, and thank you for joining today's webinar on transforming Java code testing, accelerating success with AI. My name is Jamie Motherall, and I am Parasoft's Product Marketing Manager for our Enterprise Solutions. And on the line with us, we have one of my colleagues, Nathan Jakubiak. Nathan.
Yes, I'm Nathan Jakubiak. I'm Senior Director of Development, primarily over our functional testing solutions as well as Java unit testing.
We have a great session planned for you guys today where we're going to be discussing how Parasoft's Java testing, code testing, and productivity tools are utilizing artificial intelligence to optimize static analysis workflows and unit testing practices. In today's session, we'll be sharing some exciting new generative AI capabilities, and we'll also review how Parasoft's own proprietary AI algorithms are transforming Java code testing, enabling higher developer productivity for our customers. Now, before we dive in, just some quick housekeeping. If your view of the slides or when we get to the demo portions appears to be a little bit blurry, please be sure to adjust the video resolution in your BrightTalk window. That's in your browser. And it also helps to maximize the presentation to full screen if you haven't already done so. Now, if you do have any questions or if you have any issues, please submit those comments in the Q&A area, and one of our colleagues who's on the line will reach out to assist you. Now, without further ado, why don't we just dive right on in? Now, we have a lot planned for you today in this presentation. We're going to start with static analysis and discuss some of the challenges to static analysis adoption and how applying AI technologies can help to optimize static analysis workflows and help to accelerate the remediation process. Then we'll go through a quick demo showcasing some of these capabilities. From there, we'll discuss unit testing, barriers to successful unit testing initiatives, and how AI can be applied to help development teams streamline test creation. Then we'll drill down into the benefits AI brings to unit testing practices. From there, we'll discuss how AI can also be applied to test execution to accelerate the validation of code changes. And then we'll dive into another quick demo session where we'll show JTest's AI-powered unit testing capabilities. Now, without further ado, let's dive right on in. So starting with static analysis. Now, as you probably know, static analysis is a widely adopted practice for quality and security assurance. Many application teams start with static analysis as it's really the low-hanging fruit of software quality practices and is extremely beneficial to catching defects early in the application development lifecycle. Static analysis is a great place to start when it comes to increasing quality, as it tends to be easy to implement. It can often be integrated into both developer IDEs or into CI/CD pipelines for automated and continuous code scans. It provides little disruption to developer productivity, especially when integrated into the IDE, where the developer does not need to leave their workspace in order to fix issues. And it shifts left the identification and remediation of defects so that they're found and addressed before they become larger and more costly problems to fix. And in the end, it results in higher quality code. However, software quality is still a costly problem for many companies. This number, 2.41 trillion, is from a 2022 report from the Consortium of Information and Software Quality. So let's take a moment to discuss how implementing or successfully implementing code level testing and static analysis can help you to reduce costs. As you can see in this chart, the later a software defect is found, the higher the associated cost of remediation. This is due to the detective work needed in staff resources and engineering hours to understand the defect, locate it within the tech stack, and determine a path for fixing the root cause of the issue. This detective work impacts developer productivity, and as less time is allocated for new code development, it ends up impacting the productivity more and more. Most defects are introduced as the code is being written. So by applying code level testing like static analysis and unit testing, developers are able to identify the issues before they become that costly problem to remediate and before they start to impact the customer experience or your company's brand name. So if static analysis is already pretty effective at reducing costs, finding those defects early, and increasing code quality, Why do we need to optimize it with AI? Well, even though static analysis is typically easy to implement, there are still some challenges or pitfalls that could impact development teams' productivity. So, we're going to take a moment to explore some of these challenges and how AI can address them. Static analysis noise. Many organizations will start running static analysis at different stages. And in some cases, when the code base is large and complex, the results from running static analysis scans can be overwhelming. When a development team gets thousands of static analysis findings, it can be difficult to filter out what violations are crucial to fix and what violations are more just noise. AI optimized workflows can help teams to more easily identify which violations need to be prioritized and which can be ignored, enabling teams to quickly reduce the workload of static analysis tasks. Compliance requirements. Many organizations are required to follow specific coding guidelines, such as OWASP or CWE for security. Addressing these violations often takes knowledge of the standard and specific rule, and not every developer is going to be an AppSec specialist. While the static analysis tool you have will be able to identify the defect or vulnerability in the code, it's still up to the developer to fix it. And not every developer has the skill set, knowledge, or experience needed to efficiently fix a violation, especially when it's related to a compliance standard. And then finally, time for remediation. Many static analysis solutions do offer documentation for each violation, and some offer examples of code fixes to help with remediation. However, it still requires the developer to refocus their efforts and their time from writing new code to instead analyze the code with the violation, analyze the rule and documentation and the suggested fix example, and then apply it within the context of their code base. Time spent on violation remediation can impact overall developer productivity. AI can be leveraged to help mitigate all of these challenges and help development teams to optimize their workflows so that they can very quickly sort through the noise and remediate the critical violations. So let's dive into how Parasoft is leveraging AI to optimize static analysis workflows and help teams to triage and remediate faster. This is the fun stuff. Parasoft offers a reporting and analytics platform called DTP that'll analyze static analysis results and testing metrics build to build. It offers ML-based widgets that display static analysis classification results based on past user actions. As certain violations are prioritized and others suppressed or ignored from build to build, the LM under the hood analyzes these decisions, storing this historical data for future prioritization. The AI learns from these triage actions and is then able to provide recommendations on how to prioritize other static analysis findings. Having a way to easily classify findings based on the probability of the violation being fixed or ignored can make a big difference in accelerating the remediation process and reducing the burden on development teams. As you can see here, we first had 5,000 static analysis violations. The AI sorted the findings based on the data it learned from analyzing past triage actions of our development team and grouped the findings to make it easier for the team to understand what violations should be prioritized for remediation. You can see it went from 5,000 violations to only 456 that it's identified as being ones that should be prioritized to fix, while the other violations have been sorted into a review category for future efforts. DTP's AI will also analyze the root cause of static analysis violations and group related violations together. This gives development managers the ability to assign a cluster of static analysis violations to one developer who will fix the code addressing all the violations at once. This streamlines that remediation process and also reduces work duplication across the development team. DTP's AI will also analyze past triage actions and take notice of what type of violations specific developers tend to remediate. When assigning violations back for remediation, management is then provided with actionable recommendations on what violations to assign to specific developers based on what violations they have remediated in the past. Finally, now that the developers have their quality tasks, the violations have been filtered to reduce noise, clustered by root cause, assigned to each developer based on their individual skill sets and past triage actions, the developers can easily use Parasoft's new generative AI fixes to quickly remediate the violation and get back to writing new code. The goal here is to keep up the performance of the developers as they work through fixing important code issues. So at this point in the presentation, I'm going to turn it on over to Nathan, and he's going to go through a quick demo of our AI and ML static analysis prioritization widgets in DTP and our static analysis code fixes with generative AI in the JTest IDE. Right, take it away, Nathan.
All right, great. So here I am looking at Parasoft DTP. I have a dashboard that I've configured for reviewing the static analysis violations in my project. You'll see here in the example that I have here that my project has about a little over 4,000 violations reported against it. I have already performed the training on my team's past actions as far as triaging some of the previous violations that we've already addressed. And so based on that training, I am now being recommended that out of those over 4,000, I need to fix about 1,400 of them. So it's roughly a third have been prioritized as likely violations for me to fix. Now, the rest of them, I still may want to review, but those 1,400 are the ones that I would likely want to start fixing first. We'll see here in this bar chart, they get actually grouped by confidence. So basically the confidence that the system has that we want to address them. So we start with the highest confidence ones first and go from there. If I drill into this, we can actually see the individual violations, and you'll see here this predicted action shows me the confidence that I would want to fix this based on my team's past triage actions. So, you can see them. I have them sorted based on that probability. One other thing that Jamie mentioned is the recommendation on which developer should fix the violations based on past actions. And so you'll see here, I also have a recommended assignee. So based on the past actions, it'll recommend the username of which developer should fix them. If I switch back to my dashboard, one other thing that Jamie talked about was the grouping violations based on a common root cause. So we'll see here, I have my violations hotspots widget, and we can see that different violations in different files got grouped. So if I click on one of these, what I'll see is, I have a violation reported against this particular line of code. I think this is part of a flow through the code. And so multiple other classes are implicated in that and multiple other rules. But these all got grouped together because if I fix the issue in this one place, it should address all of them at once. So with these techniques, this helps the development teams to triage the actions, identify which ones will give the most bang for the buck, which ones are most likely I'm going to want to fix, grouping them together so that if I fix one thing, I'll address a number of them all at once. And then it helps me assign who is the best person to fix them. So once they've been assigned, once we've decided who should fix them, typically the developers that are fixing them are going to be in their IDE. So now I'm looking at IntelliJ, where I have Parasoft JTest installed. Once violations have been assigned to me, I can import them into my IDE. And so I have the set of violations here that I want to work on down here in my Parasoft findings view. So I'm just going to pick one of them. I have a little Spring application here. And one of the violations that got reported was for some of the security rules that I ran, where it's complaining that the code disabled the protection against cross-site request forgery. So this is a possible security violation. And the code in question is highlighted. We can see here that it's disabled. Now, in a typical stack analysis workflow, I could just go look at the documentation, and the documentation's here describing the rule, why it's important, example for how to, what went wrong, how to fix it. And so I can read that and apply it to my code. However, we have recently introduced capability to generate a quick fix based on integration with the LLM providers OpenAI or Azure OpenAI. So let me get that going. So instead of just looking at the documentation, I'm going to ask it to generate me a suggested fix for this violation. And we'll see here that a dialog will come up. And what is happening here is we have provided information about the rule as well as the method where the violation occurred to OpenAI. And we've asked it to do some analysis of the rule in the context of the specific code, describing whether this is an actual violation based on the code, and if so, how to fix it. So it's giving me some analysis of why it thinks it is an actual violation, some of the concerns that you might need to consider, because, in many cases, static analysis rules, you don't apply 100% of the time, right? There are exceptions for good reasons. So it'll explain some of those. And then we can see here that there is a code snippet that was generated showing me how to address the violation. So we've got a comment here where it says it removed the call to disable. And in fact, it enabled the CRSF protection. So at this point, if I like this code, I can choose to copy the code, and then I could come into my method and actually replace the method, or if I wanted to copy and paste certain code snippet, part of it, I could do that. And this provides me an updated quick fix. Now, obviously this is coming from OpenAI, so I can't blindly trust it. I need to review it. There might be some additional changes I need to make, but personally, this CRSF violation is one that I'm not that familiar with. And so this is very helpful to me in understanding what the violation is and how to fix it. So it helps me get started much quicker. So at this point, I'll switch it back to Jamie. That's all that I had to show for the stack analysis piece.
All right. Thank you, Nathan. Okay, so thanks for that quick demo of DTP's AI-based widgets and our new generative AI features to accelerate remediation. We're pretty excited about all the benefits that AI is now bringing to static analysis. So we're going to do a quick recap on what those benefits are. And as we do go through this list of benefits, keep in mind that each of these benefits does have a direct impact on those 4 main business drivers you see on the side: speed, quality, reducing risk, and reducing costs. So let's go through them real quick. First off, you saw there how we can help reduce the noise when it comes down to static analysis results. By using AI, teams can filter through static analysis findings, and they can reduce the burden for development teams, helping them to identify what to prioritize. They can do faster triage and remediation, because not every developer is going to have the knowledge necessary to fix a static analysis code violation. And while we have documentation on each rule that'll get you part of the way, the documentation for static analysis rules is not context sensitive to the code under test, and hence requires the developer to still have a heavy hand in implementing the fix. Generative AI, as you just saw, helps developers quickly fix the code to be in alignment with that rule. And as an added benefit, it helps the developer to hone their skills and understanding of how to fix industry-specific or security-specific code violations. It leads to faster remediation, which means more remediation in the early stages of development and less defects in production. Less defects in production means less disruption to the developers to find and fix bugs found by QA. And when bugs are found in the later stages of development and production, engineering hours must be allocated for the detective work needed to fix the problem. This can be costly and time consuming, and it takes time away from developing new code, impacting productivity, which can result in delays or projects going over budget. And then finally, AI can also lead to a better developer experience. Getting development teams to use new tools can be challenging. And at the end of the day, the developers really want to focus on writing new code. If we're able to reduce the noisy test suite, grouping violations by root cause, assign violations backed by skill set, and use AI to help generate those code fixes, much of the time consuming activities associated with static analysis can be mitigated, and developers can altogether have a better experience with using static analysis or implementing quality assurance practices. Now, we're going to switch gears a little bit here. We're going to talk about unit testing. If there are any questions about the static analysis side, please make sure you pop those into the Q&A session so we get to them at the end of the presentation. So let's talk about unit testing. What are some of the common challenges of unit testing? Well, first, the tests that you're creating need to be high quality tests. Your goal just cannot be to drive high coverage. The tests have to actually catch problems by verifying the behavior of the code. Second, achieving code coverage targets can be challenging. When your application does have a high code coverage requirement, meeting that coverage number can be daunting and time consuming. Third, the maintenance of the unit test is another burden. You don't just create a test and you're done. When code changes, those changes will trigger test failures that require maintenance to ensure they reflect and validate the current behavior. Oh, am I sharing? I think something went wrong there. Nathan, can you confirm?
Yes, it did.
It looks like it dropped.
Why don't we share again?
Yeah, let me try that again. All right, everyone can see it? Perfect. All right, we were at, in the end, it's all about reducing the amount of time and effort it takes to create these tests, because unit testing takes a lot of effort, it's time consuming, and it can be very overwhelming to development teams. And this is why we tend to see an industry average where unit testing adds about 40% overhead to a development team. This high cost of unit testing is a direct factor of why many unit testing initiatives are not always successful when it comes to implementation. So we're going to break it down in a little bit more detail and talk about the barriers to successful unit testing initiatives. So unit testing is time consuming. At the end of the day, developers want to spend their time writing new code instead of spending time writing and maintaining test cases to test the code that they just wrote. When the code is more complex, the time it takes to write the test cases also increases. Ensuring that unit tests are isolated from external dependencies such as databases, external services, or the file system is crucial. Mocking and stubbing these dependencies takes technical knowledge, and it's also time consuming. It often requires an understanding of mocking frameworks like JMockit, Mockito, or PowerMock. And if the code is not properly isolated, testing results may be inaccurate. Test maintenance is, again, a very tedious task. When the code has been changed, test cases need to be modified to support the changes, and the unit test suite needs to be re-executed to ensure that the modifications to the code base have not broken existing functionality. Keeping regression testing suites clean and well-maintained is a necessary step to ensure code changes have not broken existing functionality in your software. Some organizations also enforce the attainment of a specific code coverage standard or goal to gauge a level of release readiness. 80% test coverage tends to be a commonly accepted and enforced metric in commercial software. Now, achieving comprehensive test coverage means testing all code paths and edge cases, which can be challenging. And teams often spend lengthy engineering hours chasing their code coverage number that they need to meet. Legacy code. Legacy programs are often comprised of code that is old and has not been touched, modified, or reviewed by development in a long time, but is still in use. Legacy code can be problematic code that has not been written to be easily maintainable, readable, or following modern expectations for quality. Often, this code has been primarily manually tested or minimally tested. When legacy programs are targeted for either refactoring or modernization, it's important to create a unit testing suite for regression testing to ensure that the code modifications made by the development team do not break existing functionality. However, when the code has been written where it's not following best practices and is not easily maintainable, or the code base is overtly complex, the creation of unit tests becomes more challenging and even more time consuming for development teams. And then finally, there's a resistance to testing. As unit testing, again, is time consuming by nature, development organizations often juggle with the choice of allocating time for the creation and maintenance of test cases versus focusing on creating new code and increasing their development productivity. Organizations that sacrifice unit testing, though, for a faster time to market are gambling with the increased risk of bugs in production. So, how does AI mitigate these barriers and challenges to help teams successfully adopt unit testing practices? Well, Parasoft JTest is very unique because it provides a combination of AI powered, automated, and guided workflows. First, it enables teams to leverage its AI to quickly bulk create unit tests for any uncovered code within their code base. This is the autonomous test creation, and where we see development teams rapidly advance from low coverage metrics to up to 60% coverage by leveraging JTest AI bulk unit test generation capabilities. From there, developers can use our AI assisted test creation workflows to analyze the mostly covered code and the associated unit tests, and then are provided back AI generated recommendations on how to augment their test cases to drive better code and set regression controls to better isolate the code under test. Parasoft's newest AI feature exists within this automated test creation or test augmentation workflow. And it provides another way for developers to augment their test cases so they can reach their code coverage requirements with meaningful, maintainable, and effective test cases. Assisted workflows can help you reach your goals, whether you're trying to reach a specific coverage goal or whether you're working on a complex unit test with specialized logic by hand. So let's break it down a little bit further and drill into the assisted test creation workflow. Let's take a deeper dive in what JTest Unit Test Assistant and Parasoft's new LLM generative AI capabilities provide. The way you want to think about this is JTest provides developers with a whole toolbox on ways that they can take existing JUnits and customize them, enhance, and modify them to support their needs. Our JTest Unit Test Assistant is already very powerful. It can already help developers to easily enhance their test cases through AI-powered recommendations, helping them to easily generate mocks and stubs, assertions, parameterizations, or it will show them also which test cases to clone or augment to drive those higher levels of code coverage. The new generative AI integration enables a new path for test augmentation that gives developers even more flexibility. The developer selects the test case they want to have augmented and will ask the AI through a natural language prompt describing their requirements to refactor the test case in a specific way. This provides unlimited flexibility for the developer to quickly augment their test cases in ways specific to the requirements of their program. Now, why not just use OpenAI for unit test generation? Let's do a quick comparison between JTest AI unit testing and just using LLM OpenAI on its own. JTest provides highly consistent test generation, where just using the LLM OpenAI on its own suffers from kind of high variation in test creation. You can ask it to generate a test multiple times with the same requirements input, and you're going to get sometimes different results each time the test is generated. JTest offers also very high quality, consistent output in the tests it generates, where the LLM technologies alone can be prone to errors. They're really only as good as the information they've been trained on and have been known to generate inaccurate results. So that's important to keep in mind. JTest also is a scalable way to create test cases because we offer that bulk unit test creation. We're able to help you to more easily and quickly drive coverage. LLM technologies are very low in scalability as each test case needs to be individually generated. And then finally, JTest is an on-prem solution where LLM technologies tend to be more SaaS oriented. Not every company will allow the use of SaaS tools. In the end, it's the combination of JTest and generative AI that gives the developers best of both worlds. It results in very consistent and a very scalable test strategy for unit testing practices. There are also some additional barriers to LLM adoption. Some companies have policies that don't allow the use of LLM providers. This is why Parasoft has actually enabled our new LLM integration as a separately licensed feature in our software. If our customers are not allowed to use LLM technologies, they can still use JTest bulk creation and unit test assistant test augmentation workflows. We just turn off that little feature in the licensing for them. Another issue when it comes to barriers for LLM adoption is performance. LLM can be very slow to generate output. If you have to wait a long time for each individual test case to generate, it will definitely impact your productivity and slow down your unit test practice. And it can give users too much confidence. Trusting the AI too much can lead to lazy oversight and quality issues related to inaccurately generated test cases. So all test cases still need to be reviewed, especially when you're using LLM to create that test case. So let's switch gears and we're going to talk a little bit about validating change faster and pull requests and speeding up the feedback loop by using AI. Why do we want to optimize this? Well, first off, when validating change locally, developers must submit a pull request to have their changes reviewed and approved before they can be merged with the primary branch and source control. This usually entails lengthy wait times as they wait for feedback from other team members on the impact of their changes. By utilizing Parasoft's AI-powered test impact analysis or smart test execution, which is a part of our Java productivity solutions, developers can get immediate feedback on pull requests, validating their changes faster and reducing these costly wait times. Running complete test suites every time to validate a code change is inefficient and it consumes a high footprint of DevOps hardware and infrastructure. Test impact analysis enables development teams and DevOps engineers to focus on only the test cases impacted by code modifications so that they can rerun just those impacted test cases. This accelerates that feedback loop and also frees up DevOps infrastructures so that they can support more pipelines, leading to higher productivity while at the same time reducing individual project costs. Now, it's important to note that the application teams will still need to consistently run their full test suite, but for pull requests or situations where development needs quick or immediate feedback on the impact of changes that they've made, they can employ test impact analysis to streamline these processes. So how does Parasoft's smart test execution with test impact analysis work? Well, first, it analyzes your test suite to determine what code each test case covers. Then it analyzes what code has been modified or changed since the last build. It then identifies for either the developer or the DevOps engineer the test cases to run that correlate with those code changes. Now, here you see a quick snapshot of how test impact analysis might look in the wild. On the left, I have a trend graph of the full regression suite from one of our internal projects. It's over 4,000 tests. On the right, we see how many tests were run with each build when test impact analysis was turned on. We're intelligently running the subset of tests necessary to validate that what code changed in that build. Now, notice that the y-axis on the graph on the right, there's a 0 missing. Not only does this speed up the feedback loop for development for in-sprint automated testing, but it can also considerably free up infrastructure costs and provide you with savings by not running your entire regression suite every single time you need to validate a change. Now, at this point, I'm going to turn it back on over to Nathan, and he's going to go through another demo for us, this time focusing on the AI-powered test creation for uncovered code, test impact analysis, and our new generative AI-based test case augmentation features. All right, go ahead, Nathan.
All right, great. So I'm back in the IDE, and I'm going to demonstrate a workflow where I make a change, a small change in the code of my application. I'm going to show you how test impact analysis will help me identify which unit tests I need to run locally, and then show you how the unit test assistant in Parasoft JTest can help me generate tests for the new code that I just wrote. So let's get into it. I have a role service class here, and I have this add new role method, and I want to add a little bit of additional logic to this method. So I'm going to add a case where a user cannot add a new super admin role because that requires special privileges. Very simple code change. I added that code. Now I'm going to direct you over to the top right here. I have my impacted unit test view, which comes as part of Parasoft JTest. And if you're used to writing code, you'll know for my role service, I probably have a role service test class, which is the unit test for this class. And I know I need to run those. But the question is, are there any other classes that I also need to run? When I look into the impacted unit test view, I see indeed that it identified that role service tests needs to be rerun. That's as expected. But I also noticed that there's another unit test, global users creator test, that I also should run, because this unit test is more of an integration style test, and it also touches the role service class. So one of the things that happens during a development when I'm changing code, especially if you have unit tests that are a little more not as solitary, they more work together with other classes, you often don't know which test to rerun. So the impacted unit test view gives me a quick view on what I need to rerun. And it even gives me an action where I can run all those tests with one step. Now, before I do that, though, I know that I need tests for this new code that I wrote. So to do this, I'm going to demonstrate how I can do that using the unit test assistant in JTest. I'm going to choose the package that this class is in, and I'm going to choose to create a test suite. Now, from here, I have a couple different options. I can create tests for all classes in this package. And in fact, I could have done it at an entire project level if I wished. Or I can choose the option to create tests for only the methods that I modified. So in this case, that happened to only be in one file, but you can imagine a case where I may have modified 10 or 20 files, and I want to generate tests for just those files. So the modified methods only option allows me to do that. So let me go ahead and start the process, and it's running here in the background. Right now, at this point, it's analyzing the code and identifying test cases that need to be added to this code. One of the optimizations that it makes is that it reviews, based on the coverage, it'll review which code is already covered by existing test cases, and it does not add new tests for the already covered code. So this is an optimization because I don't want it to create me redundant tests, more tests to maintain, right? So it's only, in this case, adding me tests for uncovered parts of the code in these methods that I modified. So we'll see here, it says that it created me 3 test cases. If I switch over to my role service test, we'll see here one of the new tests that it added was indeed a test for this case where I'm trying to add a super admin role. And it also added an assertion. In this case, we expected the exception to be thrown. So it configured the test to expect this exception to be thrown. So now I have new tests for my code. If I go ahead and run those tests, I'll see now that I have coverage for this new code that I wrote. So I have the green coverage markers, and I can see now that code is completely covered. So this is just a brief example, but it shows you how I can use the unit test assistant to quickly generate tests for code. And as I mentioned, I could do this for code with tests. We optimize it to only cover the uncovered code, or I can do this for code that has no tests at all, and I can do it at bulk all at once. I also showed you how the impacted unit test view will help me identify which tests I need to run. Now I'm showing you an IDE workflow. One of the places where our test impact technology or test impact analysis technology is the most effective is in a CI/CD pipeline. So I'm not going to show you that today, but you can imagine how, as part of a pull request workflow, integrating our TIA or test impact analysis technology will allow you to identify and run just the tests needed to validate the changes in your pull request, significantly speeding up the pipeline, how long it takes to run your pipeline. Now, one more thing that I want to show as part of my example today is one of the new features that we just added in the last release, which is our integration with OpenAI and Azure OpenAI. So the integration that we added allows a user to enhance or augment an existing unit test that they already have. So I'm going to take one of the unit tests that we just created, and I'm going to use our improve my test action, which gives me a dialog giving me some different options. We have a number of what we call improvement types built in. So we can ask it to generate edge and error cases, convert to a parameterized test, or we can do completely custom things. We have some examples, but the idea here is a user could craft some kind of custom prompt saying, please do whatever they want to do to their unit test. Maybe they want to add mocking, maybe they want to, whatever they want to do, something custom, they can create their own generated prompt for that. For my example, I'm actually going to choose the convert to parameterized test, but I'm going to customize it and say, I want to convert this to a parameterized test, but I want, let's see, actually 5 data sets. I'll say with 5 data sets. So I wanted to create a parameterized test with 5 data sets. So I can submit that. And so much like we saw with the stack analysis, it'll give me a description of how to do that. We see that it's generating the code. So in this case, this is the code for using the JUnit params library, because I'm using a JUnit 4 in my project right now. So it generated me the test. And then as part of JUnit params, you need to create a separate method to provide the data. So we see that it created that with some example options for the data that I could use. And same as with the static analysis, I can copy the code and paste that into my class. So basically what you can see here is we have a lot of flexibility, a lot of power for a developer to instruct it to do whatever they want. And the benefit here is that it's in context of the test method that they're working with, allowing them to quickly interact with the OpenAI or Azure OpenAI LLM, and getting that feedback directly back in the IDE where they can use it as they're working on their test cases. So with that, I'm going to switch it back to Jamie.
All right. Well, thank you for that great demo. You know, as you saw, there's a lot of power when it comes down to accelerating unit testing with AI. And today's demos have been just kind of quick overviews. So I highly recommend, if anyone wants to take a deeper dive, to come to the Parasoft website and request a technical demo where you'll see end-to-end everything that JTest can offer. Now, let's do a quick recap on the benefits AI brings to unit testing before we wrap up. So, first off, faster and smarter test creation with test cases that validate functionality and effectively drive code coverage. It provides more stable and maintainable test cases when it comes down to test generation. And customers are able to reach higher levels of code coverage faster with the AI recommendations. They also are able to enjoy faster feedback from pull requests with the test impact analysis capabilities. And all of this results in higher quality as well as increasing productivity as developers are more efficient in their using unit testing practices and can spend more time on new code development. And it reduces project costs as more defects are found and fixed earlier in the development lifecycle. Now, that's it for today's presentation, but if you do have any questions, please be sure to submit them in the question area of your BrightTalk window. We'll get to that in just a minute. I want to thank everyone for joining our presentation today. And I do want to point out that, again, today's demo was very high level. It was a quick look at our capabilities. We're really just scratching the surface of what Parasoft can do when it comes down to testing for Java applications. If you'd like to request a deep dive technical demo, I highly recommend requesting one today on the Parasoft website, or you can use the QR code that's there or the URL that's there for you as well. And one of our colleagues will reach out to you to schedule a quick intro meeting and the demo for you. We also offer a free 14-day trial of JTest. So if you just want to get started right away, you want to get your hands on the tool and experience how AI can help you to optimize your static analysis and unit testing workflows for yourself, you can go ahead and download our free trial today and get started. And of course, if you have any questions as you're using the free trial, we're always happy to help. You're always welcome to reach on out to us. Now, let's take a look at some of the questions we have in the chat. All right, give me just a minute here. So I do see one. Nathan, are you ready for some questions? Looks like we've got one on, does test impact analysis only work on Parasoft generated test cases? Do you want to take that?
Sure. No, it does not work only on Parasoft generated test cases. It'll work on any generated test case. Well, any test case that you have. So any JUnit test that you are running, whether you wrote them yourselves or whether Parasoft generated them, it'll work for those. So no problem.
Test impact analysis is also a part of some of our other solutions. So if you're really interested in the benefits that this can provide, I highly recommend reaching on out to us. We have another question here that says, OpenAI is not allowed at my company. Can I still use JTest to generate test cases? I know we talked about that briefly, but do you want to go into a little bit more detail there on our proprietary AI?
Sure. So yeah, the core capability for generating unit tests is Parasoft's algorithms. So in that case, we're not interacting at all with any external LLM providers, so that you can run that completely on-prem, disconnected from the internet. There's nothing being shared there. So that provides complete peace of mind if you don't have access to using something like OpenAI.
Mm-hmm. And again, we have structured it within our licensing so that if you are barred from using LLM providers at your company, we can simply turn off that feature in the licensing and your users won't have access to it. It has to be turned on with the approval of our customers. I see one here that says, can I use JTest to generate test cases for my entire project at once? We did address this, but I think they probably popped this into the questions before we got to it. So did you want to reiterate on that one?
Yes. So I mentioned how you can select any level from a method to a class to a package to entire project and generate tests. So you can do it in bulk as you wish.
And then there's a couple questions here. Let's see, which IDEs are supported?
So JTest is inside Eclipse and IntelliJ.
Then I see one also. Oh, go ahead.
Yeah, I guess I should mention that we do have some basic support in Visual Studio Code. The unit test generation piece is not in Visual Studio Code, but you can work with static analysis violations there. But the most of the functionality I demonstrated today would be in Eclipse and IntelliJ.
Mm-hmm. And then there's one on, is there a limit of the number of test cases that JTest can generate in a single class and for a single application?
There's no technical limit. We will generate as many test cases as we think is optimal for, optimally covering the code without creating redundant tests. There are some licensing considerations. So depending on how your license is structured, you may or may not have some limits on that just based on the licensing. But from a technical perspective, there would be no limitations. Mm-hmm. It's just, we just create what we consider the optimal set of test cases.
And then I see one, so there's one on, will you be sharing the slide deck? We'll follow up with folks afterwards regarding the recording so that everyone does have access to this. And then last question I think we have time for today, because we are a little bit over. I see how much time is saved using JTest for unit testing versus manually creating tests by hand.
All right, that's interesting. So we've had a number of customers who, when they were evaluating JTest to bring it into their organization, they did a side-by-side comparison. So they would have some people take some uncovered code and try to write tests for it by hand. And then they would take JTest and use the combination of the automatic, the autonomous test generation plus the augmentation workflows to create effectively get the same kind of coverage on their tests. And then compare how much time it took one versus the other. And we've consistently, with multiple clients, we've consistently seen 50% or better time reduction. So it's a pretty significant reduction that our customers have seen when they've adopted it.
I think that's all the time we have for questions today. If anyone does have additional questions, again, I highly recommend reaching on out to us. If you haven't had a chance yet, please do explore also the attachments section under the BrightTalk window. We have in there the link for the free JTest trial. We also have a case study that you can read up about some of our customers' return that they've gotten from using our tools. We have a little bit of white papers in here about getting started with unit testing with JTest, as well as our static analysis security support. And then we also have the link where you can request a full end-to-end technical demo. I want to thank everyone for their time today. We really appreciate you all joining us for our presentation, and we love the excitement around AI and are very excited to share with you these new AI features on the generative AI side as it continues to build on our story for helping developers to increase their productivity and optimize their testing practices for Java. Again, thank you everyone for your time today. Have a great rest of your day and a very happy holiday season coming up. All right. Have a good one, everyone. Bye-bye.